Here we see a question, and you see there are linear equations, and such type of questions are solved using augmented matrix. But wait, we can solve this one without augmented matrix. Let us see how can we solve this one. I write in red, and I mark the equations 1, 2, 3, and the last one is 4. Okay, so if you see the first and third, I write here from first and third. Okay, from first and third we can write x plus 4 minus t equals to x plus y. This is from this comes from the first, and from the third we have 5 minus z. Okay, I think you are clear. And let you see on the screen 3 things are equal, so let these 3 things to be k. Say okay, from here we can find the values for x, y, z, t in terms of k. So our t will be t equals to 4 minus k, and z equals to 5 minus k, and there is one more relation, 2 more relations. 2, if you see 2, then from 2 we can write from 2 we can write x minus 2t equals to 7 by 2, and from here we can find the value of x. X will be 7 by 2 plus 2t. Okay, then 7 by 2 plus here we replace t by 4 minus k, because t is equals to, here you see t is equal to 4 minus k. I am doing this because all the variables, I want all the variables in terms of k. So here 2t, so at the place of t I type 4 minus k. Okay, and from here 8 here will be 23 by 2 minus 2k. So we got x as well in terms of k. Now using this equation we get this equation. In this equation we get y in terms of k. And how can we do? Let us see. I have just marked a relation. From that relation y equals to k minus x, and k here minus. I just evaluated x in terms of k, which is here. You see, this is x, 23 by 2 minus 2k. So at the place of x I place 23 by 2 minus 2k, but this will be plus 2k due to the minus sign here. Okay, and this will be 3k minus 23 by 2. So we have got, I show you, here is our t in terms of k, here is our z in terms of k, here is our x in terms of k, here is our y in terms of k. So we have expressed the variables given in the question. In the question you see there are 4 variables x, y, z and t. All the 4 variables have been expressed in terms of k. Now there is one more relation. I write that relation, I show you that relation. That relation is this one. Okay, so I now work for this relation. So in this equation, first side, I mean left hand side, is x minus 3y minus z minus 10t. Okay, and our x is, you see here, our x is 23 by 2 minus 2k. Okay, thereafter you see minus 3 by 3, and y is our 3k minus 23 by 2. Thereafter minus z, at the place of z we can type 5 minus k, and the last one is minus 10t. So minus 10t minus 10, and at the place of t we can write 4 minus k. Okay, now we should simplify this one, because in this you see there is only one letter, that is k. So here will be 23 by 2 minus 2k minus 9k plus 69 by 2 minus 5 plus k minus 40 plus 10k. Okay, now if you see the constants, I mean the terms without k, here is 23 by 2 and here is 69 by 2. If you add these two, then this will be 92 by 2, and you know 92 by 2 is 46. Okay, and in that 46 subtract minus 5, then will be 41, and again subtract minus 40, then will be 1. So the terms without k is 1. Now we work for those terms which have k. So here you see, I show you in red. Okay, minus 2k minus 9k minus 11k, and here plus k, it means minus 10k, and here plus 10k, so minus 10k plus 10k, it is 0. So there will be no terms having k. Okay, so what does it mean? What does it mean? I have evaluated this one. I show you again this one. 2b1 means it is independent of k. I write the same thing. Independent of k. It means that whatever be the value of k, the value of this thing is 1. Okay, so it does not depend on k. It means it does not even depend on x, y, z and t. You may think that how can I say, because I have shown that the value does not depend on k. does not depend on k, but you see that here I show you t depends on k, z depends on k, x depends on k, y depends on k. All the variables depend on k. All the variables given in the question depend on k, but this value does not depend on k. This means that the value of this thing is independent of k, which in turn means that this value of this expression is independent of x, y, z and t. This means that the system of linear equations given in the question have infinite solution. Okay, and you see here it is 1, and here you see lambda, so lambda will be 1. First thing, lambda will be 1, and second thing is it has infinite number of solutions. Then combining these two, if you see the options, then option C is our correct option. Okay, so this question is